let's take a look at solving an equation by factoring when the factoring isn't just quadratic. We'll take a look at this. Now solving this equation could be done by looking at my possible rational roots, but if I can actually factor the equation, then it's going to be a little bit easier. It's going to save me some time. So first thing I'm going to do is notice that this is a four-term polynomial, so it's possible that factor by grouping might work. Now in factor by grouping we do this. We group the first two and the last two, and we hope for a common factor just within the pairs that we've circled. So I notice that there's an x squared in this first pair, so I pull it out. I just like pulling out the greatest common factor. That's what I'm doing. So then it leaves me, if I'm going to pull out something from if I'm going to pull out a greatest common factor out of a binomial, then I'm going to be left with a binomial. So that's x squared that comes out, and x plus 1 remains. Now this plus right here, I'm just going to copy it right here. Right? That's the same plus. Now I'm going to factor out, looks like a 2 is the only thing that factors out of that one, and yet when I factor it out I get the very same thing in the parentheses that I got on the first one. Now because that happened, these are the same factors, I'm actually going to take that common factor. Now think about it. This could be considered, let me underline these in blue here, between the yellow plus, right? We have this blue thing plus this blue thing. Within each blue thing we actually have a factor of x plus 1, right? It's a factor. So I'm going to take that common factor and I'm going to pull it out to the front as a greatest common factor. Now think about it. Look what we have left. We have, after that thing came out, we have this remaining. We have x squared plus 2 remaining. All right? So inside the parentheses we're going to have x squared plus 2. Now we have to put parentheses around the front because that was a binomial that we pulled out. Not just two individual terms, two individual monomials, it was a binomial. So now let's take each individual factor and let's set it equal to 0 and we'll solve. So we know that x is -1, that's one of our roots. And then this one, x squared is equal to -2, that's kind of an interesting one, right? So this one is actually going to be x, whoops, wrong color. This is going to be x is equal to, now this right here, the square root of -1 times the square root of 2 is the square root of -2, right? So I can split it up. Now this gives me I, and this really I can't do anything with the square root of 2. So I'm going to have the plus or minus I square roots of 2. Now it looks like that we were going to have 3 roots, and we actually did. Plus or minus, that's 2 of them, I square roots of 2, and then -1. So factoring could even give us some imaginary, which is what it just did. So be on the lookout for that. Alright, the second one, I'm going to try to factor it by grouping as well. I'm going to group those two and those two. Now, if I end up having to rearrange to get the two pairs to have a common factor, that's fine. It's not completely unusual. But these are set up pretty nicely. I'm going to go ahead and pull out the x squared out of this first one. I'm going to be left with a 3 and x and a 2 here. Let me double check. I multiply back together, this right there and that right there. Do I indeed go back to my original? And yes, I do. Now, on this one here I have a minus, so I'm going to copy the minus. Okay, so I copy the middle sign, and then I'm going to pull out, looks like I'm not going to be able to pull out anything but a 1, and that's okay. Sometimes we just pull out a 1. And so I'm going to have 3x, and then I have -2. Now, here's a problem. You notice that these don't match. Well, I need to do some checking before I even determine that this is correct, because if I go back and multiply -1 times 3x, do I get my -3x? Yes. But if I multiply negative 1 times negative 2, I don't get negative 2 up there. You see that? It's supposed to be negative 2. So that means that this had to be adjusted. So many times when I have a minus here, that means I have to adjust the second sign, okay, to make it really true. This right here, when I distribute, must go back to that, must equal that. I have to make it equal that. Okay, so well now that I have it equaling that, it really does mean that I have, it means that I have those two factors in common. All right, so I'm going to pull out the common factor there. And I'm going to be left with, let's look at it, I'm going to be left with this. I'm going to be left with x squared minus 1. Put that parentheses there and there, and I'm ready to go. 3x plus 2 is in addition to x squared minus 1. This is going to be x equals minus 2 on each side, divided by 3, going to be negative, it's going to be negative 2/3. All right, add 1 to both sides on that. I've got x squared is equal to 1. This time when I take the square root, everything's okay, right? I'm not taking the square root of a negative. I'm going to bring that over here. So I have x is equal to, but it's still plus or minus 1. So here are my roots, negative 2/3 and plus or minus 1. So that's 3, and it does show me that I should have 3 roots. Okay, let's go ahead and take a look at one more. This one's a little bit different in that I'm not going to factor it by grouping. I don't have 4 terms. I am going to look for the greatest common factor, and I do see that there's an x that can come out. So that's going to leave me that. Okay. Now I'm going to do my version of factor by grouping. You may do something called bottoms up on this problem, but that's not what I use, and so I'm not going to get into that here on this video. I actually do have a video on factoring by grouping on YouTube, so you can look that up. But here's what I do. There's 6 times 4 is 24. I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. That's it, and I'm trying to make an 11, so here we go. I have a 6x squared plus 3x plus 8x plus 4. Now I'm ready to do my factor by grouping. So I have x, and inside here I'm going to have a factor of 3x, and that's going to be x plus 1, it looks like. Pardon me, 2x plus 1 plus, factor out a 2, and I get 2x plus 1. Well, it looks like it's turning out pretty nicely. I'm going to double check. Does that times that give me 6x squared? Yes. Does that give me 3x? Yes. Does this give me... No. Okay, see, you should check your work. That should be a 4. There we go. 4x, 4 times 2x is 8x, 4 times 1 is 4. There we go. Now let's keep going. Alright, so my common factor of 2x is going to, 2x plus 1 is going to come out to the front. That leaves me with a 3x plus 4. Alright, so here are our 3 roots, or excuse me, our 3 factors, pardon me, my 3 factors. 2x plus 1, and 0 is equal to 3x plus 4. Okay, let's see what, that one's already finished. And minus 1, and I get x is negative a half. I also go minus 4, negative 4 is equal to 3x, and I get x is negative 4/3. Alright, so there are my 3 answers. Alright, thanks for watching. I hope it helped.